Okay, so this video is on implicit differentiation as opposed to explicit differentiation. So when we think of a function, we think of it explicitly like this. And when we take its derivative, whether we call it y prime or we call it f prime of x, or in this case, we're going to think of it as dy dx, which is just delta y, delta x, or the change in y over the change in x. This is another way of writing the derivative, but it shows us that we're taking the derivative of y with respect to x. So taking the derivative of y with respect to x, we just simply 3 times 2 is 6x, and that's the derivative. We're done. Okay, and that's called explicit differentiation. Had the function been given to us in the form 3x squared minus y equals 5, this is an implicit function. It's implied that it's a function. It's not in function form. It doesn't say y equals, like we're used to seeing, or f of x equals. You can see the x, you can see the y, but it needs to be converted into this form, and then you can say, okay, what's y prime, or what's f prime of x, or dy dx. So this is implicit. It's implied that this is a function, and so we put it into function form. And that's no problem, and then we can take the derivative. So that's what we would do. If you were given this function, you would put it into function form, take the derivative, no problem. Same thing for something like this. If you said xy equals 1, that's implicit function. It's implied that that's a function. You can see it. If you divide both sides by x, you would get y equals 1 over x, and then you could take the derivative of that, or you could rewrite that as y equals x to the negative 1. And then if you were asked what's y prime, you would just say negative 1 x to the negative 2, or negative 1 over x squared. Okay, and this is explicit differentiation, and that's what we've done in the past. So what I want to focus on is a function that you can't easily convert explicit to an explicit function. So if you had something like y to the third plus y squared minus 5y minus x squared equals negative 4. Okay, so it's a function. It has x's and it has y's and it has inputs and it has outputs, and you can graph this function. You could put it into Desmos and see what it looks like. But it's an implicit function. It's not explicitly written in the form y equals, and it wouldn't be easy to rewrite this. In fact, it's very difficult to try to get y by itself, because you've got y cubes and y squareds and y. So if you just wanted to solve and get y by itself, it would be extremely difficult. So we can take the derivative implicitly, and to do that, we're taking the derivative with respect to x. So the derivative of y with respect to x, and in order to do that, you need to do the chain rule. So here's what it looks like. I'm going to work out the steps for you. The first thing you would do is say, let me take the derivative of both sides. So I'll say dy dx of y to the third plus y squared minus 5y minus x squared is equal to the dy dx of negative 4. So I'm just taking the derivative of both sides of the equation. We know that this is going to be 0. The derivative of a constant is always 0. So we can get that out of the way. And here you're going to take the derivative of each one of these individually, each of these terms. So here's where the chain rule comes in. The derivative of y cubed is 3y squared, but then we have to take the derivative of y with respect to x, so we say dy dx. You could also say y prime here, but we'll call it this for now. Plus the derivative of y squared is 2y dy dx, because you also have to do the chain rule, the derivative of y, and then minus 5 dy dx again, minus 2x, because the derivative of x squared, or negative x squared, is just negative 2x. Okay, so this is the trickiest part right here, is just taking the derivative and seeing that that's the chain rule. So y cubed is 3y squared dy dx, because you have to take the derivative of y with respect to x. Now you can factor all these out. You can move this 2x to the other side here by adding 2x to both sides. So it looks like this. Factor out all these dy dx's, and you get 3y squared plus 2y minus 5. And so if you want to know what dy dx is, or the derivative of y with respect to x, just divide both sides by this expression, and you will get dy dx equals 2x over 3y squared plus 2y minus 5. And that's implicit differentiation. So this will tell me the slope of the original function at any given point. But normally when we want to know that, we just plug in the x value, because a derivative generally just has an x, like you see up here. If I want to know the derivative of this original function at any given point, I could just plug in an x value. But here I'd have to plug in an x and a y. So I need an actual solution from the original equation, so a point on the graph, and then I could plug that point in here, and it would tell me the slope of that function at that point. So this is your derivative, and if you did it implicitly, that's it. That's implicit differentiation.